Here are Alpha Centauri A and B, as seen by the Cassini spacecraft just above the rings of Saturn. Assuming it's worth the trip, you'd have to travel a distance 30,000 times the orbit of Saturn to reach them. Put another way, if Earth to Saturn is a meter, then Earth to Alpha Centauri is New York to Chicago. To put the journey into perspective, consider Voyager 2, now on its way out into the galaxy. After a series of gravitational assists from Jupiter and Saturn, the spacecraft is traveling at about 62,000 kilometers per hour. If it were headed in the right direction, it would need another 73,000 years to reach Alpha Centauri. To reach the speed needed to escape Earth's gravity, 25,000 kilometers per hour, the space shuttle carried 15 times its weight in fuel. A NASA study showed that to send a shuttle-sized craft to Alpha Centauri in 900 years would take an unbelievable amount of fuel, 10 to the 137th kilograms worth. That's more than the entire visible universe. There are several promising advanced propulsion concepts on the drawing board, including fuel-efficient plasma engines, which accelerate a spacecraft gradually to high speeds. It won't get us to Alpha Centauri in anything close to a human lifespan. To go that far and that fast, a pre-Apollo project called Orion called for a series of controlled nuclear explosions to propel a spacecraft to high speeds. The project died amid concerns about the impact of nuclear explosions on the environment. Back in the 1970s, a group of scientists unveiled designs for Daedalus. This giant fusion-powered craft would have had to carry 50,000 pounds of fuel. The plan was to accelerate to 12% the speed of light and reach a nearby star in 50 years. Other plans have included ramjets with vast magnetic fields that scoop up a fuel supply of hydrogen ions, or solar sails powered by the solar wind and by lasers stationed along the way. Then there's the rocket of choice in science fiction, powered by the most potent fuel in nature, antimatter. In James Cameron's Avatar, a fusion antimatter hybrid engine powers a 1,500-meter-long spaceship. It makes the journey to Alpha Centauri in just 6 years. Antimatter consists of electrons and protons, but with their electrical charges reversed. Whenever it comes into contact with normal matter, the two annihilate each other in a ferocious blast of energy. Only trace amounts can be found in the universe today. For example, in the high-energy environments of black holes. It's so powerful that a mere 10,000th of a gram is about all it would take to send a spacecraft to Jupiter. Current designs for an antimatter drive use magnetic fields to isolate and channel the fuel. The idea is to merge a stream of protons with a stream of its antimatter opposite, antiprotons. A magnetic field pinches or compresses the combined streams into a narrow beam. Annihilation then produces an ultra-high energy laser that shoots out the back of the craft. That causes a recoil effect that pushes on the magnetic field produced by the beam and propels the craft forward. Antimatter can be produced on Earth in giant physics labs like the Large Hadron Collider. Here, scientists accelerate atoms to nearly the speed of light and blast them together to release their fundamental constituents. The yield is so small that the cost of producing just a gram's worth of antimatter would be upwards of $100 trillion. And the stuff is so volatile that storing more than a few atoms at a time remains a significant challenge. If specialized facilities were built, the cost could drop by one estimate to as low as $10 billion per gram. One idea would be to station an antimatter factory in space, powered by the 1 billion watts per kilometer delivered by the sun. Another is to harvest antimatter already produced in space. The idea is that cosmic rays, interacting with interstellar particles, send about a kilogram of antimatter flying into the solar system every second. Some of it has been shown to circulate in radiation belts that surround the Earth. Theoretically, it could be captured by a large magnetic scoop that sits in a high orbit above the planet. Short of traveling to another solar system, there may be good reasons to develop antimatter propulsion. An interim mission would speed beyond the orbit of Pluto, sending back close-up images of objects in the Kuiper Belt. A longer-distance probe could reveal new details about the Oort cloud, a vast realm of comets that envelops the solar system. Once out there, it could sample interstellar particles or deploy an interstellar telescope. To make it all the way to Alpha Centauri within 50 years, an antimatter probe would have to accelerate to around 10% the speed of light, over 100 million kilometers per hour. High velocity has its perils. At such speeds, even dust has enough mass to destroy the craft. A magnetic shield would be needed to clear the way. If it could be done, there may be other destinations to consider. At least 22 stars within 12 light years of Earth. Any way you look at it, the first interstellar voyage will be a quantum leap for humanity.